I think part of what I want to communicate today, though, is that science, I think, can also help think us more deeply and critically about who we are and the basis for our differences. And I think in many instances, it can lead us as people to be more compassionate and perhaps celebrate and better understand our differences and our diversity rather than making judgments about them. I should tell you that evolution has a very deep interest in making sure that our species is diverse. By having a wide array of phenotypes, as it were, or differences, the species is able to better cope with the inevitable or frequent and often catastrophic changes in environment that often allow only a subgroup of the population to survive. So diversity from an evolutionary point of view is absolutely critical. So that diversity is expressed for almost every one of our features, including, not surprisingly, based on the title of the lecture, the amount of fat we carry. And as I mentioned in the preamble to this, nature has a problem. It has to manage our calories, which are stored as fat, in an intelligent way, leaving us fat enough to survive the inevitable famines that took place over the course of our human history, but also not so fat that we've developed some of the diseases that I'm going to tell you about today. Join me in trying to think about it the way a scientist might. Now, part of the problem here is that for almost every disease save obesity, people don't generally have an opinion about what causes it and would leave it to the experts. So if I were up here talking about heart disease, ulcer disease, mental illness, or cancer, or AIDS, I think if someone asked you what causes these problems and how would we treat it, you'd probably react that, well, let's leave it to the experts. That's not the case, I think, to the same extent for obesity. So let me ask for a show of hands. Who has an opinion about obesity? What causes it? I'm surprised that's all. Well, that's actually not as much in many audiences, but certainly a lot of you have an opinion, and it shouldn't be surprising that you do. It's all over the newspapers, and as we'll mention in a moment, it's frequently the subject of television shows. To follow up on this a little bit more, let's go to the first poll question. There's a wide array of weights, and some people, and we'll define this in a moment, are morbidly obese. Let's ask the question, is it fair to hold the morbidly obese responsible for their condition? Is it their fault? Let's see what the poll says. 43% say yes, 57% no. Well, I would say, based on my experience, this is an exceedingly enlightened audience. In a very general sense, I can think of three possible explanations. There may be more, but I think in general they can be grouped into one of the three headings. Obese people, you might argue, suffer from a lack of willpower, and they don't exercise the same sort of restraint for food intake that lean people exercise. I find this point of view is generally favored by lean people. Other people argue this is a lifestyle problem. The problem is our environment, this modern environment where sedentary lifestyle combined with overeating or free access to calories, that's what causes the problem. And then a third possibility is that there's a biological explanation for differences in weight that has to do with our genes. Now, I want to emphasize at the start that these are not mutually exclusive explanations. And for many other human traits, what we have is a network of genes being modulated by environmental factors and willpower, conscious factors that might affect behavior and local environment for that individual. And we really, in the end, would like to understand how these all interact. And I think that's the challenge. Unfortunately, I think much of what's public discussion on this centers on assumptions about the powerful contributions of willpower and environment to the exclusion of the powerful effects of biology. Let's take another poll now with respect to these three possibilities. Which of the following do you think is the most important factor causing obesity? Remember, I think we can all agree that probably all contribute at least to some extent, but which do you think is the single most important problem? Vote A for lack of willpower, B for lifestyle, C, biology and genes. Okay. Do you have any poll results? Most people think it's lifestyle, 57%. 18% think it's primarily willpower, 25% biology and genes. Now, of course, lifestyle involves personal choices, so there is an element of willpower there. So let's start talking about willpower. But it's this basic drive to eat when you're hungry that leads to most diets to fail within 1 to 2 years. So 70 to 95% failure rate of dieting. So willpower is not the whole story here. What about lifestyle and environment? We talked about this with the poll, and the sort of evidence that you'll see with to support the idea that this is a lifestyle problem is calculated here, where people index obesity rates over time and see that obesity rates are going up. They say substantially, and people argue that our genes haven't changed, it must be the environment. Our genes don't change over this time frame. Actually, that assertion belies a lack of understanding of how natural selection actually operates, but let's set that aside for a moment. You would imagine from this that there's never been obesity before. In fact, let's go to a quote: "No age has ever afforded more instances of corpulency than our own." Anybody know who said this? Anybody want to guess when this comes from? This is a British physician, Thomas Short, in 1727. Well, obesity is not a new problem. The first sculpture ever found, the Venus of Willendorf, is shown here on the left, and there were clearly obese individuals from the 1800s. So where does this disconnect come from? So I think environment is clearly important, but in a quantitative sense, it's not of the magnitude that you would imagine it to be when you hear rates increase by 50%. Now, there's another question beyond what in our environment is responsible for this increase, and that is today, where everyone basically has free access to calories, is weight so variable? How is it that in an environment where nobody goes hungry anymore, which is the case in the U.S. generally, how is it that weight is so variable, and some people can weigh more than 400 pounds and other people less than 100 pounds? And the answer to that question, I'm going to argue for you in a moment, is genes. That genes play a very dominant role in explaining phenotypic differences in a population at a moment in time. I'm a geneticist, so it probably doesn't surprise very many of you that I'm going to argue that biology and genes play an important role in accounting for differences in weight. You can compare kids who've been adopted, to their adoptive parents and their biological parents, and what you find is that adopted children resemble their biological, not their adoptive parents. Does everyone see why that would be evidence that this would be genes and less environment? And then the classic way was just mentioned: systematically compare sets of identical and fraternal twins. Since identical twins, monozygotic twins said more precisely, share environment and genes, and dizygous twins share environment and less genes. If monozygotic twins are more alike for a trait, we can assume there's a genetic basis and actually quantitative. So look at this. The monozygous twins are remarkably similar. The dizygous twins come in all different shapes and sizes. And if you actually want to be really stringent, you can do these studies looking at identical twins separated by adoption. And you still find that the incidence of obesity is very highly correlated among the identical twins. Now, using such methods, you can assess the genetic contributions to a particular trait. The actual number here refers to the percent of the variance in the trait that can be accounted for by genetic factors. And so what you can see are a number of traits have genetic contributors. Never, for these conditions, 100%, but significant genetic contributors for height, schizophrenia, diabetes, hypertension, alcoholism, and heart disease, height being the highest. Where do you think obesity falls on this table here? Top, middle, or bottom? Top. Well, top is right. You should get a T-shirt, but I'm not supposed to throw them out if it's not the Q&A session. So we'll give you one later. Obesity, 0.8 to 0.9. As hereditable trait has been scored with the possible exception of height. Now, to illustrate the power of these genes, I'm going to tell you about a case report of a child in England who was of normal weight at birth, but began to develop morbid obesity beginning in infancy. And here's a picture of the kid. In addition to being overweight, he markedly overate, was pre-diabetic at the age of 4. He weighed 90 pounds with 57% body fat. His 8-year-old cousin was similarly affected, and this young girl weighed 200 pounds, which is what I weigh. Okay, 205 pounds, but it was close. Now, a clue that this might have been an unusual cause of obesity came from the fact that the child came from a highly inbred pedigree. Anyone know what that would suggest?
That their family had relations within their own family.
Yeah, that there may have been. Well, a lot of populations don't discourage first cousin marriages. So in those cases, rare genetic differences often get expressed with a frequency that's not seen in the general population. And that was the case in this kid, who was found to be deficient for this hormone leptin. Anybody know what a hormone is? Can anyone tell me what a hormone is?
A hormone is a molecule that is released from one area and travels through the body to affect another tissue.
That's right. And so leptin is a hormone I'm going to tell you more about, but because it's a hormone, it can be made in the laboratory and given back to this kid. And let's see what happens when you give this kid leptin back. He's gotten taller, lost weight, fat has fallen, and he's much less pre-diabetic than he was. His insulin levels have fallen. In addition, the people who did this work, a colleague in England, Stephen O'Reilly, gave this kid a test meal before the first leptin injection and gave it to cousins of this child who were similarly affected. And some of these kids ate as many as 2,000 calories at a single meal before they got leptin. That's about the daily caloric intake of an individual my size. And this kid at the age of 4 was eating it at one sitting. They give the kid some number of leptin injections, and now he eats the correct amount of calories at that single meal. So what's driving appetite in this kid is not lifestyle, it's not willpower, it's the lack of leptin. And you give him the leptin back, and his appetite normalizes, and actually many of the features of the syndrome are improved. So here's a picture of the kid at 3 years of age. Here's the picture now of the kid at 8 years of age, 5 years getting these hormone injections. I'd like to ask yourselves to think for a moment about what you would think about a child walking down the street who looked like this and what you thought about his upbringing or his parents' performance versus looking at a kid like this. It's the same kid. And so I think it's fair to begin to ask, might there not be other biological explanations that account for differences in weight similar to this, and genes that the identity of which we haven't sorted out yet? So at equilibrium, at your normal weight, leptin is made and you're eating different types of food. Now let's imagine you were starving or you went on a diet. Your fat mass would contract and you would make less leptin. This is now the state that led to the less fat. So you've been eating less. Now the response to low leptin is to eat more. A low leptin level is a very powerful stimulus to eat more, gain weight, and return your weight to the starting point. Now let's imagine instead that you went on a binge of eating. You spent an extended period of time eating at wonderful restaurants. You would get fatter and make more leptin, which would then suppress your intake again until your weight returned to the starting point. Now, by such a mechanism, again, weight can be maintained within a range. I'll point out to you that if you diet and your weight falls, leptin level will fall, and this is a potent stimulus to regain weight. So I thought I would close now with a final poll question. I'm a little nervous in doing this because I've been told my youth support is contingent on more people answering C now than at the beginning of the talk. But we'll go for it here. I'm kind of curious if anyone has changed their point of view. I'm hoping, I think we have a tape that'll record the original answer. So why don't you vote in response to this question, and then be happy to take a few more questions to end the session. Oh, I should have been a lawyer.